Hello and welcome. In this video, we're going to be solving mathematics paper 4 mechanics from February-March 2022, this year's paper. So without any further ado, let's get started. This is variant 4.2. So question 1, a crate of mass 200 kilograms is being pulled at a constant speed along a horizontal ground by a horizontal rope attached to a winch. You just go ahead and bring the question a little bit closer. The winch is working at a constant rate of 4.5 kilowatts, and there is a constant resistance to motion of the crate of magnitude 600 newtons. Find the time it takes for the crate to move a distance of 15 meters. Alright, so we can go ahead and illustrate a diagram that this is, let's say, the crate. It has a resistive force of 600 newtons, and the crate is 200 kilograms. Now, we do need to keep that in mind, that the crate is moving at a constant speed. In this case, it's 15 meters. It's moving at a constant speed. And the power of the crate is given as E is equal to 4.5 kilowatts or 4,500 watts. And since the crate is moving at a constant speed, I can also say that the forward force is 600 newtons. Then we can establish the formula power is equal to force times velocity. From here, we can go ahead and find the velocity as 4,500 divided by 600. Doing this, so we will get a velocity of 7.5 meters per second. So we know the velocity, and we know it's traveling at a constant velocity. So the constant velocity formula is given as S is equal to Vt, where S is 15 meters and the velocity is 7.5 times the time. So the time is going to be ultimately 2 seconds. So this is going to be our first answer. Let's move on to question number 1, part B. The rope breaks after the crate has moved 15 meters. Find the time it takes the rope breaks for the crate to come to rest. So now there is no forward force. So the forward force is 0. This is 0 newtons. And this is 600 newtons. So what we can say that now it is going to be coming to rest. So since it comes to rest, our final velocity is going to be 0 meters per second. And after it is moved 15 meters, that means the time in the break, the rope had an initial velocity of 7.5 meters per second. So now we're going to be using F is equal to ma. Okay, force is equal to mass, where the force is negative 600. Mass was given as 200 on the first part. So A can be given as negative 3 meters per second squared. So since we now know the acceleration, we can plug these into the values. So another formula for acceleration is going to be V minus U over T. From here, we can figure out T, V minus U divided by A. So 0, U is going to be 7.5, A is going to be negative 3. So if we calculate this, the time comes out to 2.5 seconds. So this is going to be our answer. Let's move on to question number 2. A particle P is projected vertically upwards from horizontal ground with a speed of 15 meters per second. Find the speed of particle P when it is 10 meters above the ground. So particle P is being projected with U as 15 meters per second. The distance it traveled from the ground is 10 meters. So it's going to be moving freely under gravity because there's no upward force. It's going to be, so the acceleration is going to be due to gravity and negative. So we can go ahead and use the formula of V squared is U squared plus 2AS. So to find out V, we put U as 15 squared negative 2 times acceleration is going to be 10, distance is 10. So if we calculate this, the velocity comes out to be 5 meters per second. Moving on to question number 2, part B. At the same instant that P is projected, a second particle Q is dropped from a height of 18 meters above the ground in the same vertical line as P. Find the height of the ground at which the two particles collide. So if you take a look at the reference frame, Q is being initially dropped, meaning U is 0, and P is being projected at U is 15. And the distance gap between the two is 18 meters. So if you find an equation in reference of P starting from the ground, this is particle P. So I'm going to be using a different color. So For p, this can be written as 15t minus 5t squared. So how did I get the formula? I'm using the formula s is equal to ut plus half at squared. This is the formula that I'm using. So from here, u is going to be 15, t we don't know, negative half times a is the acceleration 10, so half into 10 is going to be 5t squared. Now, if you take a reference for q and consider q to be the starting point, q is just going to be 5t squared. Since the acceleration for q is going to be positive because it's coming downwards, so it's just going to be 5 and u is 0. So this part becomes 0, so q is 5t squared. Now, this is where the upward direction is positive. This is where the downward direction is positive. So now we know that we have two equations in reference of two reference frames. So what we can easily go ahead and do is we just add up these two. So these two moving downwards and one moving upwards is going to cover a total of 18 meters. All right. So the direction of these two really doesn't matter in this case because one moving downwards and one moving upwards will have a total displacement of 18 meters. So we can just simply go ahead and add the two equations. So we can say that S of P plus S of Q is 18 meters. So basically 15t minus 5t squared plus 5t squared is 18. Over here we can cancel out 5t squared to remain with 15t is equal to 18. So P ultimately is going to be 1.2 seconds. So what we can now say that we need to find the height above the ground. So you have to find the height above ground. So what we got to do is we can place it. So let's go and place it on S of P. If you place on S of P 1.2 minus 5 1.2 squared, you're going to get a direct answer of 10.8. However, if you place it on S of Q, which is going to be 5 1.2 squared, you're going to get an answer of 7.2 liters. So what's the catch? The catch is if you take a look at heat, it's 7.2. So this P is coming from the top. So the displacement 7.2 you got is actually 7.2 meters from the top. And it says, the question says above the ground. So it has to be from the ground you go top. So what is this remaining distance right here? So this is basically going to be 18 minus 7.2. That's going to give me 10.8 meters. So if you're using S of Q, make sure that the distance then you get with subtracted from 10.8 to get it from above the ground. So your final answer is meant to be 10.8 meters, 10.8 meters. Alright, so let's go ahead and move on to question number 3. So question number 3, a particle moves in a straight line starting from the rest from a point O. The acceleration of the particle at time t seconds after leaving O is given as 8 meters per second, where 8 is 4t to the power half. So what we can easily do, and we have to find the speed of, so we have to find an equation for the speed. So velocity or speed equation is the integration of the acceleration equation. So you have to go ahead and integrate 4t to the power half of dt. So if we integrate 4a to the power half dt, we're going to get 8 over 3 dt to the power 3 by 2 plus c. This is our velocity equation. Now when it's starting from point O, the velocity is 0 because it's starting from rest. So we can say that v is equal to 0 meters per second. So at O, v is equal to 0, t is equal to 0. Thus, the value of c is also going to turn out to 0. So v is 8 over 3, 3 by 2, and that's it. So this is my velocity equation. So therefore, at time t is equal to 9 seconds, velocity is 8 over 3, 9 to the power 3 by 2. And that's been to be giving me an answer of 72 meters per second. Moving on to question number 3, part B. Find the time after leaving O at which the speed in meters per second and the distance traveled in meters is numerically equal. So our acceleration was given as 4t to the power of the path. Velocity, which we find out was 3 by 2. 8 by 3 to the power of t to the power of 3 by 2. If you want to find the displacement equation, that's again the integral of the velocity equation, which is 8 over 3 by 2 dt. So if you solve this integral, we're going to be coming up to 16 over 5 t to the power 5 over t plus c. This is s. So the value of c is again going to be 0 because at O, s is 0, t is 0. Therefore, c is 0. So the final equation for the displacement is going to be 16 over 5 t to the power 5 over 2. So now, according to the question, we have to integrate the s equal to v. So we have to equate 16 by 15 t to the power 5 over 2 is equal to 8 by 3 t to the power 3 by 2. So t to the power 5 by 2 minus 3 by 2. So I'm basically transferring t to the left-hand side, and then the powers subtract itself. So because of the rules of indices, equal to 8 over 3, divided by 16 by 5. So from this, I'm going to be getting t is equal to 2.5 seconds. So the question says find the time. So my time is 2.5 seconds. Moving on to question number 4. A toy railway, a locomotive of mass 0.8 kilograms is towing a truck of mass 0.4 kilograms on a straight horizontal track at a constant speed of 2 meters per second. There is a positive resistance force of magnitude 0.2 on the locomotive, but no resistance force on the truck. And there's a light rigid tow bar connecting the locomotive and the truck. So basically we have a truck of 0.4 kilograms, which is connected to the locomotive, which is 0.8 kilograms. So you have to find the tension in the string. So if you take a look at just the locomotive, right? So the locomotive has a tension plus 2.0 newtons resistive force. And there's a force F. So in order for it to travel at constant, right over here, at constant speed of 2 meters per second, F must be equal to T plus 0.2. Right, oops. So F must be equal to 0.2 newtons. Now, if F is also T plus 0.2 equal to T plus 0.2, everything cancels out. So what we can say that this is not going to be the solution to the problem. So the solution to the problem is basically that the tension is non-existent because we need some force in the forward direction for it to travel at constant speed. So this is basically 0 newtons. So the answer is going to be 0 newtons because otherwise everything cancels out, but we do need a forward force so that it travels at a constant speed. So this is going to be 0 newtons. The next question, find the power produced by the locomotive engine. So power is basically equal to force times velocity. So the force is going to be 0.2 because it's at constant speed. Velocity at a constant velocity of 2. So the question had mentioned to us that the velocity is 2, right here, 2 meters per second. So basically, this is going to be 0.4 watts. So that's my answer. All right, so this next part, the power produced by the locomotive's engine is now changed to 1.2 watts. Find the magnitude of the tension in the locomotive. In the coupling at an instant when the locomotive begins to accelerate. So basically what we're going to be doing here is that we still have a resistive force of 0.2 newtons, which is constant. You know, we will have a forward force as the power is increased. Now, instantaneously, when we're considering, right, so the entire resistance motion is 2 newtons, yeah. So at the instant when we're considering the entire motion, okay, when considering total system, we can use F is equal to ma. So the forward force we don't know, but the resistive force is 0.2, and the total mass is 0.8 plus 0.4 times 8. So from here, what we can use is powers is equal to force times velocity. So what's the power? Power is so we need to find force, which is power by velocity. So power is 1.2, and at that instant, the velocity, at the very instant, it's 2. So this calculation comes out to 0.6. So basically, 0.6 times minus 0.2.48 plus 0.4 times acceleration. Our acceleration, by calculation, then comes out to 1.2 meters per second. squared. So now what we need to do is, considering only the locomotive's frame of reference, you're going to have the forward force of 0.6, you're going to have the tension, and we're going to have the resistive force. Now the tension is existent, so it's going to be 0.6 minus t plus 0.2. The locomotive's mass is 0.8, acceleration is 1/3. From here, we can find the tension as 0.6 minus 0.2 minus 0.8 times 1/3. If you calculate this entire thing out in your calculator, tension is equal to 2/15 newtons. That's going to be our answer for number 4. Moving on to question number 5. The diagram shows a block D of mass 100 kilograms supported by 2 sloping struts AB and BD, each attached to an angle of 45 degrees at fixed points A and U respectively on a horizontal floor. A block is also held in place by a vertical rope CD attached to a fixed point C on a horizontal ceiling. The tension in the rope CD is 500 newtons and the block is in equilibrium. So find the magnetic force of each struts A and B. So the tension in each of them is going to be like this and like this. So let's just call this TA and I'm going to call this TB. So over here it's going to be TA cos 45 and in this direction it's going to be TB cos 45. The weight, the mass has a weight of 1,000 newtons, and the upward direction of the upward force is 500 newtons. So what we can basically first do is we can, resolving vertically, what we can do is it's basically equal to 500 plus TA cos 45 plus TB cos 45 is equal to 1,000. So TA cos 45, oh, sorry, not cos, I'm really sorry for this. It's basically going to be sine 45. So how is it sine 45? So if you resolve vertically, we're going to get TA sine 45, and over here TB sine 45. The vertical component of the tension. So it's TA sine 45, TB sine 45. So TA sine 45 plus TB sine 45 is equal to 500. So that will be our first equation. Now if we go ahead and resolve horizontally, what we can now achieve is TA cos 45 is equal to TB cos 45. From this, we can import a very relationship that therefore TA is equal to TB. So back to square one of the equation, we can just go ahead and write 2TA sine 45 is equal to 500, because ultimately this is going to become TA. So TA is basically 500 by 2 sine 45, which is equal to, if we go ahead and calculate this in our calculator, which is going to be equal to approximately 354 newtons. It's actually around 353.5, but you can approximate this to 354. We move on to the horizontal part B. The horizontal force of F newtons applied to the block in the block in the direction parallel to BB, and the tension in this strut AT is now 0. So the updated diagram is now just going to be that we have 500 newtons in this direction. We have a tension cos 45, so this is still 45 degrees. We have it in the T sine 45, and we have a force F newtons in this direction. There will be no force in this direction because there is no force in this strut, so it's going to be totally blank on this area. And I almost forgot about the weight. We have a weight of 1,000 newtons. So again, if we go ahead and Resolve vertically. This is going to be 500 plus t sine 45 is 1,000. So t is basically 500 by sine 45. With that out of the way, we now can go ahead and resolve horizontally. Let's resolve horizontally. So if we resolve horizontally, f is in this direction, t is in this direction. So we can basically say t cos 45 is f. So f is going to be basically 500 sine 45 plus 45, which comes out to alternate of 500 newtons. Question number 6. A block of mass 2 kilograms lies on a rough inclined plane sloping at 30 degrees to the horizontal. A light group inclined at an angle of 20 degrees above the line. Alright, so basically by force that's inclined over here, the frictional force F and a block over here. And first of all, the value of F is given and the acceleration is given, so we need to find the value of T. So if we go to this direction, T has a horizontal component of T cos 20. There's a reaction force plus T sine 20, but I think we don't need that for this one. And then we have the block's weight component, which is going to be 20 sine 30. So we can go ahead and simply use the equation F is equal to ma. Once we use that equation, we're going to have T cos 20. That's pulling it on forward, plus 20 sine 30, plus the frictional force F, which is 5 in this case. So I'm just going to go ahead and update its value to 5. Equal to the mass times acceleration. So T is basically 20 sine 30 plus 5 plus 2 times 1.2 divided by cos 20. So that's approximately around 18.5 newtons. It's not exactly 18.5, but if you approximate it, it's 18.5 newtons too. Very significant figures. Okay, the next question is find the value of mu. So to find the coefficient of friction, and since it's the same part, this is the same question, like part A, we still have to assume that F is 5 and acceleration is 1.2. So F is equal to mu r. So what is going to be r? So you found out the value of t to be 18.5. So we can basically say r plus t sine 20 is equal to 20 cos 30. So how can we figure this out? Basically, this is r plus, what is bring it a little bit downwards. This is r plus t sine 20. We know this. So what we can basically say that over here we have the vertical component of the weight, which is going to be 20 cos 30, because this is how the weight works. It's just 30 degrees. So after resolving, we can find out that r is 20 cos 30 minus 18.5 sine 20. So mu is ultimately just 5 divided by 20 cos 30 minus 18.5 sine 20. While calculating this, mu is going to be around 4.55. That's going to be the answer for your coefficient of friction. Moving on to question number 6, part B. It's given in an instant that mu is 0.8 and t is 15. Determine whether B will move up the plane or not. So when the mu is 0.8 and t is 15, I can now say that r is equal to 20 cos 30 minus 15 sine 20. Right? Instead of t, I'm writing 15. So F is equal to mu r. So I can find out the frictional force. F is 0.8 times 15, 20 cos 30 minus 15 sine 20. By calculation, F is going to be 9.75 newtons. So we can say, therefore, the total downward force is 9.75 plus 20 sine 30. This is going to be in total equal to 19.752 newtons if we go ahead and calculate this. And the total upward force, because we read the diagram, T was moving in this way, so we have the T cos 20 component. So basically, total upward force is just going to be 15 cos 20. That's going to be giving me around 14.059 newtons. So since 19.75 is greater than 14.095, the block doesn't move upwards. Finally, moving on to question number 7. The diagram shows a smooth track which lies in the vertical plane. The section AB is in the border, circle E. So the entire track is smooth. A particle P is over here at A, and over here at B. Okay, over here at B, we have a particle Q, close over mass, which is at rest at B. So for the initial part, so you're going to have particle Q. So over here, we're going to have particle P, and over here, we're going to have particle Q. This is point B. So since the curve, since the entire track is smooth, when P comes down from here to here, all the gravitational potential energy stored over here is going to be converted to kinetic energy. So which we can find out what's the speed of P when it's hitting, at the instant when it hits Q over here. So let's go ahead and do it. So basically, for particle P, for P, GPE is converted to kinetic energy. So I can basically write mgh is half mv squared because the surface is smooth, or else we would have to work with the frictional force. From here we can cancel out the masses, so it's actually 10. The height is 1.8, which is perpendicular to the given, times v squared. From here we can easily go ahead and determine that v is 10 times 1.8 times 2. V comes out to be 6 meters per second. But 6 meters per second, we now have to use the momentum conservation. So let's go ahead and use momentum conservation. So using momentum conservation for particle P, okay, I'm going to consider M1 to be particle P. So 0.5 times 6, M2 to be particle Q, 1 point times 0. So, which is equal to this new speed of particle P. Alright, the new speed of particle P right here is given after collision as 4 meters per second. So times 4, and it's working in the direction BC over here. As you can see, direction is still BC. So so we can say that plus 0.1 v is going to be the velocity of Q. So I'm just going to name it as Q. So VQ can be found out using the equation of 0.5 times 6 minus 0.5 times 4 divided by 0.1. So VQ is going to be ultimately turning out to 10 meters per second, which the question asked us to show, and we have showed it. For part B of the question, when Q reaches C, it collides with particle R of mass of 0.4 kg and at rest. Alright, so what we would like to do is to refer to the diagram. Alright, I've managed to bring the diagram here. So over here, Q is now going to be colliding with another particle R. So over here, it's going to be colliding with another particle R. That's two. So we can basically say that Q is going to be colliding with R. So for particle Q, so for particle Q, the initial velocity of particle Q is 10 meters per second, and since the entire track is smooth, since track is smooth, it will continue at constant speed. So now we can do is again use momentum conservation. So we're going to be using m1u1, m2u2, m1v1 plus m2 v2. So from here we can say that 0.1 times 10 plus r has a mass of 0.4, if I'm not wrong. R has a mass of 0.4 kilograms. 0.4 times 0 is equal to, since the particles coalesce when they come in contact, we have to add the mass. So the velocity can be easily found out by solving the equation, which comes out to 2 meters per second. Now, if we go ahead and kind of take the diagram somewhere over here, so what we now have to do is from this point onwards, it's going to travel a distance up the track up to point F. So point F has a distance of 0.4. So if we go ahead and kind of draw a diagram for this out now, 0.4, and this is H, which we don't know, this is theta. So again, then our track is smooth. So we can say that the kinetic energy is going to be now converted to gravitational potential energy since the particle first comes to instantaneous rest at F. So what we can do from there is half times m times v squared is mgh, where m's cancel out, so it's half. We know the velocity, which is 2 squared, 10 times height. So the height comes out to 0.2 meters. Now, since this comes out to 0.2 meters, what we can now easily do is sine theta is opposite by 0.4. Now, we know the value of h, so what is going to be the value of h? 0.2, the theta is sine 0.2.4, which is equal to 30 degrees. So that's going to be my final answer. For the final part of the question, find the distance from B at which P collides with the combined particle. So P, which was initially here, comes here. So let me just go and bring the diagram up the screen. So P, which was initially here, comes here, and then it keeps on moving until the combined Q goes, collides, combines, goes up, comes down, and then again re-collides somewhere, in between. And it says to find the distance from B. So you have to find the distance from B. So how can we do that? So first, we need to determine that after P has collided with Q, and while Q is on its journey to collide with R, how much has already P traveled? So Q has to travel 0.7 meters, right? 0.7 meters when it's colliding, or when it's going to collide with R. So what's the time taken for Q to collide with R? What's the time duration in that? So if we go ahead and find that out, we can easily use S is equal to Vt. So from this equation over here, so T, we can find out the value of S. So S by V. So S is going to be 7 meters, and velocity of Q when it's going and hitting R is 10, which we found out in the first question. So 0.7 seconds in total. So the time is going to be 0.7 seconds. So now we have to find out the time when this is going up and coming down once again. Going up and coming down once again. So when it's going up and coming down once again, let's go and find out the time. So first, we're going to be using F is equal to M8. But we want to use a different color for this. F is equal to M8 for this particle, because when it's not a slope, the value of the component of the weight is acting on it, which is 10 sine 30. So what we can now easily do is negative
0.4 plus 0.1 times 10 times sine 30 is equal to 0.4 plus 0.18. So this is going to be, acceleration is going to be negative 5 meter per second. So u, when these two have already collided, we found out that the initial speed was going to be 2 meters per second. We knew that v was 0 meters per second, and we now know that the acceleration is 5 meters per second. So t is basically v minus u over a. So if we go ahead and do calculation on it, it's going to come out to 0.4 seconds. Now when the particle is not coming down, now the force is going to be positive. So the acceleration is going to be now positive 5 meters per second. Since there's a resistive force or anything doesn't change. So the time, once again, starting from now we calculate the time, we're going to be using s is equal to half at squared. So at the top of the hill, if I go ahead and kind of come to the diagram,
Forgot where the diagram was.
Anyways, if we just go and refer to this tiny image here, at the top of the hill, it's going to be around, it's basically going to be at instantaneous rest. And from rest, it's going to come back down. Since the diagram is something like this. So it's now coming down back from instantaneous rest. So basically, S is going to be 0.4, U is 0, half, A is positive 5, T squared. Over here, we're going to get T is equal to 0.4 times 2 over 5, which is again 0.4 seconds. So while all of this is happening, how much did P travel from here throughout the 7 meter track? Right? 7 meters. So S of P is basically going to be 4T because it didn't travel the entire 7 meters, right? Plus the amount of distance it has traveled while Q was doing its thing. So the total time while Q was doing its thing was 0.4 plus 0.4 plus 0.7. How did we get the 0.7? At the top, right here. So plus 0.7. So plus 0.7, this is going to be going ahead and giving me 0.8 plus 0.7. So 4 times 0.8 plus 0.7 is going to be giving me around 6 meters. So this is 6. So we got our first equation. Now what about S of Q? Well, Q, what we need to consider is our starting point as B. So Q has already traveled 7 meters, right? Already traveled 7 meters. Plus, since we're trying to start the motion of Q from this point onwards, right? From here to here, where it's going to collide. So from this point on, starting from this point, Q has went up once and came down once. So Q has already traveled through this slope right here. So since Q has traveled through this slope, what can we do is we can say that when Q is coming down, so when Q is coming down, it has a initial velocity path U is equal to 0. Look at this is for Q. U is equal to 0. V is what we don't know. S is 0.4, right? So the final velocity when Q is at this point and its journey to collide again with P is going to be 2 times the acceleration was 5 times 0.4, which is 2 meters per second. So it's 7 minus 2t because, well, again, when it's over here, it's going to be at constant speed. So it's going backwards. It was already traveled 7 meters and it's now going backwards in the 7 meter position. So it's minus. So we get the 2 equations. Now finally for our answer, what we are going to do is we're going to be equating S of Q is S of P because when they collide, the displacement is going to be the same from the same point. So 4t plus 6 is equal to 7 minus 2t. So t is basically going to be 7 by the 6th, by 6. So it's t is 1 by 6 seconds. So I'm just going to use S of P's equation because S of P's equation is automatically starting from in the diagram here, starting from this point B. So this is our point B. So you can either use S of P's equation, or you can use either S of Q's equation. So S of P is going to be 4, 1 over 6, plus we had 6. So the answer for this equation is 2, 6, and 2 over 3 meters. So this is going to be the answer. And that's the end of this paper. Hope you enjoyed this video, and I'll be catching up on more papers pretty soon. Till then, peace.